So in this video we shall discuss on Zener diodes. Okay. So in the previous videos we have seen semiconductor diode, introduction, the different what is an forward bias diode, what is an reverse bias diode, what is an unbiased diode, and the diode equivalent circuits. Correct? That is the equivalent circuit for an ideal diode, for a practical diode, piecewise linear equivalent model of diode also. Also I have explained the DC loop. Okay. So this is the symbol of Zener diode. Okay. So the working of diode. So how a Zener diode works? So Zener diode at a particular reverse bias voltage Vz, when you apply a particular reverse bias voltage Vz, the reverse current suddenly increases to a very higher value due to the breakdown of the junction. This reverse voltage is called Zener voltage and the effect is called Zener effect. So in other words, Zener voltage remains constant even though the current through the Zener diode varies over a wide range. That is very important. Okay. So in other words, Zener diode, what is the property of Zener diode? Even when the voltage is increasing, when you increase the voltage, so the current through the Zener diode varies, but the voltage remains constant. Okay. So that is the property of Zener diode, which is used for regulating supply voltages so that they are constant. Okay. So the same thing is shown in the characteristics of Zener diode, as we have seen the VI characteristics of diode. In the similar way, let we plot the characteristics of the Zener diode. In the forward biased condition, the Zener diode works similar way as the normal PN junction diode. But in the reverse condition, the reverse bias voltage, what happens here is, see, initially it is same as your normal PN junction diode, but this is called as Vz. After some voltage, after the voltage Vz, if you increase the voltage, even if you increase the voltage, what happens? The current may increase. But the voltage across the Zener diode will be maintained at Vz only. Voltage will be constant. Voltage will not vary. Okay, that is the property of Zener diode. So this allows us to use Zener diode in case of voltage regulation or as a voltage regulator, because even if the input voltage is varying, the voltage across the Zener diode is kept constant. Okay, and this voltage is called as Zener breakdown voltage. It is the reverse bias voltage at which the device enters into breakdown region. This is the breakdown region. The device is entering into breakdown region but maintaining a constant voltage Vz across the device. And the minimum Zener current, it is reverse current at the knee voltage, and this is called as minimum Zener current. And maximum Zener current, it may vary, it depends. The maximum current through the device can carry without exceeding the maximum power dissipation. So the power dissipation equation PD will be equal to what? P is equal to Vi. So PD will be equal to Vz. Vz is what? The voltage across the Zener diode, which is kept constant, and the maximum current that can flow through the Zener diode. This is the maximum current that can flow through the Zener diode. So without exceeding the maximum power limitation, how much current that can flow through the Zener diode is called as maximum Zener current, and the minimum current at the breakdown voltage, which is called as minimum Zener current. So this is Zener breakdown with whatever I've explained, I've given here. Okay, so electric field also called Zener breakdown, and it is usually occurs with reverse voltage less than 5 volts. Usually for a Zener diode, the Zener voltage occurs with for a voltage less than 5 volts. So the applications of Zener diode: voltage regulating element. It can be used as a voltage regulating element in voltage regulator, in various protection circuits against high voltages, a Zener limiting clipping of as Zener limiters clipping off the unwanted portion of the voltage. It can also be used as a clippers. It can be used as a voltage regulator. So these are some of the common applications of Zener diode. Okay, thank you.